Hi, my name is Boris Maximilian Masesta, and today I'm going to explain about the assignment 2, which is the graph-based path planning for my class of Introduction to Robotics. So the objective of the assignment is we have to examine the graph-based path planning algorithm for robot motion planning. For the path planning, the computing agent of driverless car, or example, a robot, has access to a given directed graph that shows the road networks where the nodes are representing different cities, ages, the roadways, and their weight or cost are the distance in miles. So for the first part has a 30 marks, which we are required to use the Grassfire algorithm and determine the optimum path from the start node to the goal node. And for the second one part, which as a 40 marks, uses a Dijkstra algorithm to find the shortest path from the start node to the goal node. And the third one is we have to explain the difference between the algorithm and their solution for this given problem. So now I'm gonna share my solution and we're gonna go through. So for the first part, we are required to use the Grassfire algorithm to determine the optimum path from the start node to the goal node. So when we're using the Grassfire algorithm or the breathe first algorithm, we need to keep in mind that the number of ages or the total weight or the weight in the ages, which is like 2, 8, 9, we don't have to keep them into consideration. What we need to think about is just finding the shortest path from the start node to the goal node or the end node. So for us here, the shortest path we have to find from the start to the end node. But in the Grassfire algorithm, we always start from the goal node going to the start node by giving them the goal node as a 0. And then now we are looking for both direction in the north, east, west, and south, where there is another node that we can go. So for here, we gave it 0, we could go to the node of F, which becomes 1. And then we're looking, can we go in the direction of west, east, west, south, or north? We can go north again. We can only go either east side or the south side. So if we go this way, it becomes 2, becomes 2 as well here. And then we keep on going. And this is what we end up having as the shortest path. So it was 1 from F, C was 2, D was 3, and start was 4. If we decided to go with this path here, here could be 2, here would be 3, here would be 4, here is 5. So it means that I took the longest path because we have to take the shortest one, which will end up with 4. If we went here, remember this was 2, this is 3, this is 4, this is 5, and this is 6. 2, this is 3, this is 4, and this is 5. 1, 2, 3, 4. So we could also take this one as well, getting there. So these are the only possible solution that we could take from go F, R, F, C, D to start, or go F, R, E, then going to start here. That was the easiest route we could take to get to this point. Yeah. So for the part 2, you're required to use the Dijkstra algorithm and find the shortest path from the start node to the goal node. So for the Dijkstra algorithm, we consider the total weight or in the ages between the nodes. So we're required to look for the path that we get from here to here. And the shortest path that I came up with is moving from start to D, which has a weight of 3, from D to E, which has a weight of 2, from E to R, which has a weight of 2, from R to F, which has a weight of 2, and from F to the goal, which has a weight of 2. When I add them together, it's 11. And also in Dijkstra algorithm, we have to consider the direction of the arrows. For instance, we cannot, if we took a path from the start to P, we couldn't go to H from P because this arrow shows is moving from H coming to P and not from P going to H. So this is not a valid route we could take. If we decide to take this path we get here, we just end up being stuck at node A. If we took this path here, we end up being stuck at node Q. And if we decided to take a start from to E, this takes 9. And while if I decided to move from start to B all the way to E, if we add this weight, is 3 and 2 is 5. And remember, in Dijkstra, we are looking at the least total number of the weight that we can use to move from one node to another node. And this was the best route that I could take for me to get to my final destination, which was from start to D, D to E, E to R, R to F, F to G to the goal. And we have to add them. So 3 plus 2, here was 3, here was 5, here was 7, here was 9, and here is 11. And we are also required to explain the difference between the algorithm and the solution for the given problem. So I just decided to have like a table which can show us the solution. So I just consider the features for the Grassfire algorithm, which is the breadth algorithm and the Dijkstra algorithm. So the basic principle we say in Grassfire algorithm is similar. It's a uniform wave spreading from the start node. And for the Dijkstra, we explore the path starting from the source node based on the cumulative cost. Edge weights, we treat all edge as equal, ignoring their weight, and consider the weight of the edges to find the path of the least cost. And with the path metric, we find the path with the least number of edges that traverse. And for the Dijkstra, we find the path with the least total weight. And the feature, like the typical use case, we'll say for the Grassfire algorithm, mostly used in grid-based path finding, where all the moves costs have to be the same. And for the Dijkstra, it's used in a scenario with the weighted graphs, like road networks and routing. And for the memory complexity, it's a big O of N, as it needs to store the wavefront number for all the nodes. And for the Dijkstra algorithm, it's O of V, which V stands for the vertex, as it needs to keep the track of the best path and the cost to each node as it's finding the best route, moving from one node to one. Thank you so much, and that's it.